there's many publications from here. But today, on behalf of the student from Vietnam, and I also know just one student, PD student from Vietnam, maybe Miss English, so that's why I feel like to show some research achievement regarding to the integrated river basin management and apply for in Vietnam. So in Vietnam, we have facing with many problems like natural hazards like typhoons, drought, tropical, and also floods. So you can see from here we have many river basin. For example, Hồng Thái Bình River Basin very important to supply water for the Hanoi capital located in the north region. Mekong River Basin is a very important supply for the water in the south region, and it's not in central part. Vu Gia Thu Bồn very important to supply for the Da Nang city, young city. That's my main case study. You can see here every year many typhoon hits effect to the Vietnam. Not only Vietnam, but maybe also effect to the Philippines, Taiwan, and Japan also. So you can see usually after typhoon hit to the region, floods will be coming and also effect to many people living in the river along the coast of Vietnam. So that's why you can see from here, last year Yagi typhoon. So maybe you can see here effect not only for Vietnam but maybe Philippines also. So Yagi was the strongest typhoon hit to Vietnam, maybe over 3 years. So you can see here the total rainfall around is 9,000 millimeters, and also effect to the Hanoi capital. And you can see here flood occur in Hanoi city, the capital of Vietnam. And you can see here some information effect by Yagi typhoon. Very much in the for Vietnam, not only for Vietnam. So I also usually typhoon almost affect to central parts of Vietnam. You can see from here. So here we have one case study. River basin, Vu Gia Thu Bồn River Basin. It's very important to supply water for the Da Nang city, located in central part. Very important for central part Vietnam. Da Nang city is a young city. I think maybe some students here already visit Da Nang city. But now basin facing many problems. You can see from here. Dam development in upstream, sand mining activity in the downstream and middle, and now under impact by climate change. So combined with some the human activity here like water transfer, now combine all of this already affect to many things in the Vu Gia Thu Bồn River Basin. So I will show you some picture here. Flood effect to the Da Nang city located in downstream of the Vu Gia Thu Bồn River Basin in the September 2022, and also in the Hoi An city, in the same time, seeing the floods in downstream of the Thu Bồn River. So now I will show some our activity and our research to apply for the Vu Gia Thu Bồn. The first, I will show the long-term impact assessment of the hydropower dam and climate change and land use on the flow regime. So because today time is limited, so I will show some so quickly, but I will show some paper we already published. So if you want, you can download and read more here. So you can see here, we apply many methods to quantify how dam combined with the climate change and land use effect to the stream flow for the Vu Gia sub-basin and Thu Bồn River Basin. And we also combine which Giao dam how effect to the stream flow in the basin. And here we also quantify how impact by riverbed sand mining effect on the water transfer rate between the Vu Gia and the Thu Bồn River. You can see here, in the Vu Gia Thu Bồn River we have two main rivers, Vu Gia River and Thu Bồn River, connected by Quảng Huệ Channel. But Quảng Huệ Channel transfer not only for stream flow but also sediment, combined with the human activity like sand mining and also dam development in upstream. Combine all of these effect to the water transfer between the Vu Gia and Thu Bồn River. That's why effect to the downstream region. And we also quantify how the dam operation, we call hydro peaking, how effect to the downstream for the water intake supply for the agriculture and also domestic supply in downstream region. And here we can see we assess many dams located in upstream. using some method like here and quantify how it affects along the river system from upstream to the downstream region. And we also quantify how it affects to the water level and combine with the river beds how it affects to the grain size distribution also. For the coastal region, we also quantify from upstream to the downstream and also coastal region. How combine how it affects not only from upstream but also from the coastal region. So from here we can see reduce sediment from upstream because due to the dam development, because when dam built, we will start sediment in the reservoir. And combined with the human activity like sand mining in the middle and downstream, it's reduced sediment supply for the coastal region. And now combined with climate change, typhoon and many drivers will be affected to the coastal region. Here you can see some, and we also using some methods like camera here. We install some camera and collaborate with some university in Vietnam to quantify how it affects oil in the coastal. You can see from here some picture. After that, human and natural will be affected to the river basin. But after that, how it affect for its assessment, for its path, start from upstream to downstream. We should to clarify which one is effect for its assessment from upstream to downstream here. And after that, how it affect to the downstream region. Finally, we can see combine all of this and now under impact by climate change, how it affect to the salinity intrusion and also water quality, how it affect and to the water supply for the people and also agriculture. And here we can see some data we measure for the water quality in the downstream region. Okay, so now I will show you, because now you can see climate start effect to many regions, and also it's also effect to the Vietnam and also in the Vu Gia Tu Bồn. That's why we want to downscale climate, how is to quantify how it's affect to the river basin. So we can see here originally data for the CMIP6 with the 25 resolution, but now we try to downscale to the 10 kilometer for whole Vietnam, and after that we will assess for its catchment like here for its climate zone with a different scale, large scale, small scale, and medium scale here. Start from north to central and also the south region. And now we already selected 3 case studies. Saigon Đồng Nai, located in the south region, the main water supply for Ho Chi Minh City, the economic zone of Vietnam. Several river basin, the main tributary supply water for the Mekong River basin, and also Vu Gia Tu Bồn, the river basin, the main water supply for the next city. You can see this finger to show the resolution before and after downscale. So that's why we can contribute and assess for its sub-basin, start from upstream to downstream. And here we can see some results. Before we assess how it impact by climate change, we will, based on the data in historical, we can compare before and after downscale. How perform of the data scale compared with the observation. And you can see from here for the stream flow and sediment, we can see after downscale, the results from downscale so good compared with the observation. You can see here. And after that, we will quantify in the future how the impact of climate change using the data scale on the stream flow and sediment. You can see here. So after that, we quantify how it affect to the floods, drought. Okay, how it affect to flood, drought for its SSP. Okay, so finally I will show the activity in the Mekong River basin. So Mekong River basin is very famous and very important. It's covered by 6 countries from China to Myanmar, Laos, Thailand, Vietnam, and Cambodia. But we select Vietnamese Mekong like major case study. Why we select Vietnamese Mekong Delta as the main case study? Because this region very important for Vietnam. It's the food security for Vietnam, rice for which 95%, providing employment for 85%. So now Beijing facing many problems. You can see from here like flood, drought, climate change, bank erosion, sea level rise, and many dams built in the upstream, so it will be effect to downstream region. So summarize, we found that now for driver effect to the Vietnamese Mekong Delta, you can see from here dam development, sand mining activity, climate change, and combined with sea level rise. We have a more than 10 year research in the Vietnamese Mekong Delta, start from Justice project. We build and install many equipment along the river system, conduct many field survey, collaborate with many research from Vietnam, Singapore, Taiwan also. We have many research from Vietnamese Mekong Delta, and now under ABN projects, we collaborate with many groups from Japan, US, Germany, Japan, and Cambodia, and one person from Taiwan to apply the natural-based solution we call floating dry. I think maybe floating dry is the same with the green, related to green energy from some students here. So we select the floating dry like natural-based solution, and also increase more income for the farmer in the downstream in the Vietnamese Mekong Delta. And you can see from this video to see how it's different from normal rye and also floating rye. This means why we can have we can win-win by adapt with climate change, so apply normal natural-based solution, and so increase more income for the farmer. And now we have planned to extend to downstream, not only for downstream. We will understand how the upstream effect and all and driver to downstream region in the Vietnamese Mekong Delta here. So the first thing we can see here, we already collected many data sets for dam, many infrastructure like reservoir lakes and barrier from upstream to downstream here. We collect more than around 1,621 infrastructure in the Mekong River. And after that, we apply some hydrological model like SWOT here to set up for whole catchment. And you can see here results for calibration and variation for stream flow and sediment. And after that, we will quantify under impact by climate change combined with the dam operation, especially for the new dam to be operation in the future, near future, maybe around 2028 and 2030. How we affect to the stream flow start from upstream to downstream for each SSP. You can see the location for each hydrological station in the Mekong River basin here. And also how we affect to the sediment for each SSP in the future, and also compare with the historical. And finally, I will show here in the future, maybe as some hydrological station under impact by climate change combined with the many dams in upstream, especially new dam operation, it will be reduce sediment in the along the Mekong River system, and finally it will be have a huge effect to the Vietnamese Mekong Delta. So that's why we should provide more information to give the maybe for the people and government living in the government in the downstream here, to have some policy to adapt with how sediment reduction and how the farmer, how people will adapt with the sediment reduction, and also stream flow change or alteration from here. Okay, I think maybe time is limited, so I would like to show very quickly for this. But if you want to have more information, you can contact or access this link I shared on the first slide, and you can find more information, more publication or something from this website. And I want to give more chance for Wei San and Desmond to show for the research of life for the Cameroon, and also life for the in the Japan for the Naka River. So thank you very much.
Thank you, Dr. Min. I think, yeah, we have a very extensive research, more than 10 years or 11 years, since I started my work at Kyoto University. So I built this delta research, and we studied extensively the Mekong River basin, and also the Vietnamese Mekong Delta. So we call delta research. Delta research. So we have different delta research work in Vietnam, central part of Vietnam, and also Nile Delta. We are doing as well. So the next,
Do you have coastal erosion problem in Taiwan?
What?
Coastal erosion.
Coastal, yeah, but our department is not involved with this. Mostly in reservoir sedimentation,
yeah,
and also we have some drought problems in 2020. So underground water management is also proposed. Yeah, and I think professors downscaling the research of the whole entire area, I think is also
good.
yeah, they're ready. Yeah.
Okay, please start.
Good morning, everyone. Good morning to you, our visitors. We are delighted to have you. So I'll present to you my research. I'm a T3 PhD student, and the specialty of my research in this laboratory is the inclusion of the socioeconomic characteristics of our study area. And my research is titled Integrated Approach of Flood Risk Mapping and Management, Considering Sediment Plastic Debris Impact and the Social Characteristics in Urban Slums in Cameroon. Cameroon is a Central African country. So our research is built principally on around 4 main objectives. The first one being to develop new approach for flood risk vulnerability mapping. Second, quantifying SPD, which stands for sediment plastic debris. And this is going to be like the major parts of our presentation today. And the third objective, to design methodology for flood risk mapping, considering the impact of this sediment plastic debris and the social characteristics. Now, what is sediment plastic debris? So normally we have, of course, sediment production within the sub-basin. And in addition to that, being the fact that this is an urbanized sub-basin, we have plastic production. It is natural to consider that based on the characteristics of these differences in the characteristics of these two, maybe their transportation will be very much different. But under certain conditions, they mix, especially under low flow conditions. These two have the tendency of mixing together and forming what we call sediment plastic debris. Sediment plastic debris can either result from anthropogenic or result to anthropogenic hotspot, which for us is sediment plastic debris, which results from plastic debris directly dumped by humans, or natural hotspots, which are as a result of maybe the topographic and hydrologic characteristics of the sub-basin. So my research is looking at all this complex altogether, and the very first one which we will look at will be the transportation, the production, the transportation, and the accumulation of this. In our study, we are making use of tools like drone surveys. We are making use of cameras for pictures, and then we are also integrating machine learning in order to monitor this production, transport, and the accumulation of this sediment plastic debris. One of such paper which we did was sediment plastic accumulation transport effect in urban rivers, and how this will eventually cause effect on the river channel morphology. Our hypothesis is the fact that when sediment plastic debris accumulates in low quantity, of course, it can easily be washed by flow. But when it accumulates in considerable amount, it has a tendency of causing changes and affecting the channel morphology of very small urban rivers. So in this study, we made use of sentinel images, and then we equally made use of geolocalized plastic hotspots, which we mapped during field visits, and then we equally made use of UAV images, which we obtained on the field through a couple of drone surveys. And principally, we were calculating the plastic index of the river, and to determine the changes. First, to determine the plastic index, and then using it to determine the changes which has occurred through time within the river channel. So here we can see the location of the area where we carried out our drone surveys, and here we have a couple of adjusted plastic index which we determined, and then these are some locations of the plastic hotspots which we obtained on the field. So with the drone survey and with the UAV images that we obtained through drone survey, first we obtained a drone survey before a major rain event, and then next we obtained another one after the rainfall event. And here we wanted to see how much changes has occurred along the river channel as a result of the rainfall, the interaction between the discharge from rainfall and the plastic hotspots, which this is the location of the plastic hotspot here. And we can see clearly here some changes which occurred along some sections that we cut along the river segment. So here you can see a couple of changes which had occurred, which has taken place as a result of the presence of these hotspots on the river channel. So mainly we were looking at the behavior of the channel at the hotspot. We're looking at the behavior of the channel before the hotspot and the location of the channel after the hotspot. And you can see here that we discovered that there is usually often the tendency of, as a result of accumulation here and prevention of flow to through the normal river channel, we have diversion which often occur, creating new channel in the river. We found out that there were 5 major behavior of the sediment plastic debris, which had the tendency through which it could modify the river morphology. The first one being artificial damming, where sediment plastic hotspots accumulate in a very large amount, affecting the upstream river, leading to encroachment or enlargement of the upstream river. We also had the second one, which was speculation through SPD hotspot. This is when sediment plastic debris accumulate and affect downstream river condition. And we had encroachment, bypass through sediment plastic hotspot points, and then split flow, which will often also occurs through the plastic hotspot. The main difference between speculation through SPD points and the split flow being that changes occur for the speculation through SPD, changes occur in the downstream, while for split flow the changes is seen to take place on the sediment plastic hotspot itself. So now we equally try to look at to evaluate the risks of microplastic contamination of groundwater resources in the sub-basin. The reason being the fact that this a good considerable percentage of the population still rely on groundwater resources for consumption, and we commonly call wells. So in our assessment we considered the level of protection at each water source. We considered the effect of in our assessment, we're considering the level of protection. Of course, the level of protection at each water source. We considered the influence of environmental hazard leakage factors, such as the flood risks or the wind, the effect of wind, which will, of course, have the tendency of blowing SPDs toward maybe either toward the water source. And then we equally considered waste handling and leakage factor, distance of each hotspot to water point, exposure to weather, which we mentioned, distance from road. Road here plays a factor because most hotspots, especially anthropogenic hotspots, which are directly dumped by human, occurs along roadside with the aim that the waste collection company will easily come by and collect this waste. And then we're also looking at topographic factors such as elevation and slope, and then the land use. So here we have the distribution of the water resources based on the distance to the river, based on the distance to the road. And then we also have their distribution based on the flood inundation map, which we obtained through one of our studies. This flood risk map we obtained through modeling with RRI. And so we determine the location of these water sources, of these hotspots, as per the flood risk level at each location. And then their location as per slopes and elevation. So it results, like I made mention of, about the level of protection at each water source. When we're looking at protection at each water source, we're looking at the presence or absence of a perimeter of protection. We're looking at the presence of drainage infrastructures, there's concrete superstructures around the wells or the water source, and the presence of leak which will help to completely cover the water source. So in result, we discovered that almost maybe about 30% of the wells, the underground water sources, were at considerable risks of microplastic pollution. Of course, we did not carry out a chemical analysis of these water sources to determine concretely the quantity of microplastic in each water source, but we were just trying to inform the population that as a result of this plastic debris present in the environment, it could eventually affect the underground water sources, which they use for consumption. With this, I say thank you.
Thank you, this one. Very interesting. Yeah, this time is very easy to understand. Very beautiful. Very good design. This I will use in Singapore also? Yeah, please. Thank you. Very interesting. Good. Yeah, so as you can see, we have a very large topics.
Yeah. Plastic, microplastic is also important because due to drought problems in Taiwan, drought and river flooding is all between. But underground water has, and also wetland that has microplastics inside, and you can see the birds are eating plastic, and we find inside their stomach a lot of plastic. Yeah, so that's
so
why.
So you are doing also research for this?
Another professor cooperating with them, and it's in southern Taiwan, Cheng University, and also,
Yes.
yeah, they are doing some research about that.
If you can send me information about this.
Okay, sure.
Okay, so Wei-san, end of Taiwanese.
Okay, hi everyone, my name is Wei, I'm from Taiwan. And this year I'm a third-year PhD student at DPI. And today I'm going to present our research on sediment replenishment. And we will focus on the sediment replenishment on the long term in the Naka River in Japan. And we will introduce the background on reservoir sedimentation and its effect on the sediment balance, and overview of sediment replenishment methods in Japan, and focus discussion on our study area, the Naka River. And insight from the previous study, this is conducted by Dr. Lin, and now he is graduate. And my current study about the sediment replenishment and conclusion of this topic. And firstly, I would like to introduce the reservoir sedimentation. And because the problem is a crucial issue impacting the flood control and water storages, so we need to deal with this problem. So we will conduct many methods as mentioned by Professor Sami. And in response, we will use sediment replenishment as a key strategy in Japan to deal with this topic. And as introduced by Sami and said before, we have many methods to deal with the sediment imbalance problem in Japan. And this is the map in Japan and some sedimentation impacts upstream and downstreams. And it is notable that because in my study area, the Naka River, here in the south of Japan, it has the largest amount of the sediment volume on SR. So this is also a crucial part in this area. And this is the concept of the sediment replenishment as the SR. We have mainly 4 methods as mentioned in the left video here, and also we have several distribution of the grain size. And also we apply in other places in Japan, and also overseas, as mentioned here. And this is the study area in Naka River, Japan, Fukushima Prefecture. This is in the south part of Japan here, and mainly we focus on this part in Naka River. And there are many sediment sources located in the upstream here. And this is our study area in a more detailed view of this. And in our recent study, Dr. Lin focused on this part, the firstly 14 kilometers, and I will extend to the downstream. So you will have the 2 reservoirs. One is the upstream here, and another is downstream. So it forms a cascading bend here in this area. And in the first part, it is more branded section of the Naka River, and the other part is the relative structure channel in this area. And this shows the riverbed elevation. So we would like to talk about and discuss the importance of the tracking changes in the riverbed elevation to understand the impacts of the SR and the channel morphology over time. And this is some changes in the riverbed morphology in the downstream channel. And as we can see, we have placed the sediment volume at the upstream. So year by year, you have some deposition and erosion in this channel here, as from the picture, from the arrow. And this is the previous study conducted by Dr. Lin. And the result of he analyzed the GU surveys, and he collected this is a summary from 2015 to 2018. And the right figure shows the detailed alteration of the wide reaches. It can be noticed that after the significant flood in 2015, the tower is transferred to Riffle, so it has some formation of a new morphology here in Nakamiru. And this shows the average ECI. It is the index of the river channel. So it has a correlation of the transported volume at the SR location. So which means the cement supply from the replenishment site will directly lead to the more deposition occurring to the downstream channel. And the next part is focused on the river vessel tracks here. And based on the result in 2015 and 16, the percentage of the gravel increased along the ridges, especially the M1 and M2. This M1 and M2 means the size of the segment. So M1, M2, and M3 divided by different size of the gravel or stones here. And this is a significant increase in gravel, and maybe mainly due to the supply of the cement from the replenished side and the upstream. And he also analyzed the ash volume. This is related to the types of the fish in the Nakam River. So after the flood, after the 2015, due to the limits of the flood, the transported salmon is reduced, and the ash volume is also decreasing. And this is show the relationship between the transported volume and the variation of the ash volume here. And the conclusion of the previous study, it shows a comprehensive approach in developing the SR project when deal with the ecological part and the hydraulic part. And the SR is combined and use the index of BCI, H volume to analyze the many aspects of the SR. And this is my current research focus on the salmon budget for the riverland management between the cascading dams in Nakam River. And the objective is firstly, I will conduct GSD analysis to show the distribution of the salmon and to determine the salmon distribution along different sections of the channel to show where is increasing deposition and erosion, where to place the salmon volume and how it influences the salmon transport. And the first one is the grain size distribution. We have in each year we will conduct a field survey. We will go to the Nakam River here. So this is the upstream. And we will focus on this side and this side here and take samples and analyze by ourselves. So based on our result, the distribution of the grain size is from fine salmon to crow salmon in this each locations. And we also use the image analysis to apply to the GSD also. And for the image, we can see the surface of the grain size distribution and using the sieving method to show the inside of the salmon sample. And this also shows the transfer, the shapes of the salmon composition in each area we conduct our field survey. And also I use the cross-section data to generate the DEN data of the Nakam River to show the salmon budget segregation. And due to our result, we can choose the different of DENs and also divide into salmon locations such as the upstream SR side, 7 kilometers, 14 kilometers, and the rest of the part. Because as mentioned before, this is a branding feature in this river. So in the upstream is very meandering part, and the later part is more relative strike. So I divided it into many 3 parts in this river. And this is also show the more detail of the DEN DOD result in this area, so we can know where the transition and erosion happen in this area. And because we would like to quantify the sediment budget, so we use the sediment segregation to divide the 21 kilometer river into 105 parts to show the more detail of the deposition and erosion happening in this river channel. And this is the result of the change detection of the area in each year. And this shows the value of the change detection. And this is the main result of the budget segregation. By this result, we can see from 0 to the 21 kilometers, from the upstream to downstream, where deposition happened and where erosion happened in this river channel, and how it is transported to the downstream. And we also calculated the percentage of the deposition and erosion in showing each year, so we can understand how the valuation happened and relate it to the sediment volume placed at the SR site. And this is the averaging net significant difference. It's like the river bed changes in this river channel. And this is the sediment balance of the Naka River. Because we will receive data from the dam office, so we can know how many volume they place on the SR site, and to know the correlation of the volume and the hydro event I will mention later, and also the grain size distribution conducted by the office. And because we would like to know how the outflow event influence to the downstream sediment transportation. So I also use the extreme event to analyze the discharge volume. So the figure shows that this discharge volume along this line, and this is the yearly discharge from the release from the dam. So it shows from 2009 to 2024, and also we have some extreme event. And I apply the POT method. It's like the threshold to use the value I calculate the best volume. The threshold is like around 262 CNS. So I also calculate how many events above this threshold. So we can relate the impact from the extreme event and how it influenced the downstream transportation of the sediment. So it can also include to our future work, so we can know how the relation between the hydrology data and our sediment data. And also we can know the return period analyzed by the historic event. To know and this combination allows a direct comparison between the observed extremes and their reoccurrence likelihood. So maybe we can predict the future and know based on our analyzed data. And my conclusion is the sediment composition is dominated by the gravel and the corrosive sediment grains in this site. And the sediment supply it already entered the middle part, but not already transport to the downstreams. And as I mentioned before, the hydro event, the typhoon event, drought event, as the climate change continues to influence the pattern of the distribution of the sediment transportation. So we can use the SR method to show and to know how the human infrastructure influence in the Naka River reservoir. So thanks for your attention.
Can you show the slide of this interesting hydrological analysis you made? Yes. Yeah, this one. This is very interesting, and I think will help you to combine both the sediment morphology and the main drivers for this morphological change is this variation in the flow discharge. So how you decided 260?
I use the hybrid method or the POT method. And I read from the one paper, and he used a hybrid. He used this method and compare with the GPD method. And it can show two results. One is the recommended threshold, and the other is the best threshold. And the difference is that the best threshold will have the less none of the resilience. So it will be more precise to show a broad value. It will influence the later event.
Okay, so you decided based on some statistical method. Okay, but if you go to the last slide where you have you can see many different variations of flow discharge in different years. But we understand also that the effect of such flow discharge. So until which level these 200 or 300 or 1000, I already requested you to make a correlation between water level and flow discharge, and how much effectively this will erode the sediment from the stockpile. This is of course, your statistical method is okay, but we can have another thresholds based on the real consequences of the release discharge from the dam. Do you get my point? If you go last picture, you show last picture, more, last picture. Thank you, picture. Yeah, so 260 until which level? Okay, 800 maybe here, 1000. So I already requested Lin to do that, but he couldn't do. And if you can make a correlation between these different flow discharge and water level, and this water level will result in how much sediment transported, eroded from the stockpile, and then this will be more realistic to link with the morphology. You got my point? Okay. But very interesting. Thank you. Okay.
We
So-
did something very
You
similar.
can ask in Taiwanese if you like. Also.
She's here, so
She's here.
English is okay.
Yeah, of course.
Our professor had did something in 3 of the reservoirs downstream of Zhenwen and also Nanhua, and also another reservoir called Agongdian. And downstream part, we did the dredging from the dam and put the sediment downstream.
Okay.
And during each
In the three.
three,
Wow.
we did 3, and we have done this for 10 years.
Well, Li.
Yeah,
Yes,
the deposition of we monitor each event, like heavy rainfalls, and also each typhoons. After the flood, we measure how much sediment every hour, and like the deposit here, we find a bridge downstream, we collect, we ask the students every 1 hour for 72 hours each event, 1 hour, so we get 72. So that's how we get the sedimentation result, how much amount is being produced or being sent downstream. And we monitor, I think, three major bridges up from the upstream, midstream, downstream of the reservoir. And also, by the suggestion of professor, you give her about the amount of release
Yes.
amount. But normally in these 3 reservoirs, they also have a bypass sediment
Yes.
tunnel. So that might influence the result
Mm.
of the sedimentation.
I see.
So you have to sort of divide them together. But we also use the simulation of CCHE 2D to recognize and and use also satellite images of what has happened after releasing the amount of water, and I think every few days the satellites passes Taiwan, and we know how the morphology is changing. But it's very hard because the Reservoir Bureau asks us which part is our sediment, which part isn't. I say it's very hard. It's to find how to recognize the result. So maybe I can give some information for her
Yeah,
and also
please.
for Professor.
Yeah, please.
Yeah.
That would be very supportive.
Okay.
Because sediment replenishment research, we are very much interested. It's a very important line of research in
Yeah.
our group.
Yeah. So we have done this monitoring to the seashore.
Seashore also.
Yeah. So it's a very long way for Zhengwen Reservoir downstream area. And maybe
So
I
the
could
data,
provide.
you are involved also directly in this?
One of my our professors in our institute. Yeah.
So the same professor maybe you are communicating?
I'll talk to her later.
Yeah, please go ahead. Thank you very much, Wei-san. Very interesting. Maybe some other comments overall? You can ask me, Dr. Bin, Mr. Desmond, from Wei-san. Do you have any question or any interest, any motivation? It's okay?
Emma. Your hometown.
Vietnamese.
Yeah.
What is your study?
Actually, I am in infrastructure planning and
Infrastructure.
yeah,
Very
so
interesting.
it's kind of like different. It's my
Okay,
Yeah.
construction, more construction.
but I think that all the hazard smart information is so interesting. And later when I come back to Taiwan, I will search for the link that is there, and I will read about the research, because I also have think about the climate change and hazards. It's so interesting. Yeah. So I think we later in the future also need to apply on the integrating everything in the future.
Thank you. Thank you. Okay, some other comments from Indonesia?
I'm actually interested in the Desmond
This
research.
one? Oh,
Yes.
Okay.
He was collecting the plastic from the riverine system. What bothers me is the next process about the riverine system and the plastics. How do you use the plastics?
After collection, you mean?
Yes.
Actually, we have some local companies which collect for recycling. Though the recycling is not done in Cameroon, but they collect and then sell to other companies which they take abroad for processing.
Okay, so it's not stopped in the just collecting, but also it sells out to the company.
Yes, but our job was not the collection, but
Yeah.
just marketing the location to use for our study. But while on the field, we could interact with some of the local companies which are doing the collection of this plastic.
Okay.
Yeah, this topic we just started with Desmond. We hope, inshallah, in the future we may build some new experimental model. He's trying to build now a numerical model for this, also the second step.
Yeah.
But also in the future, maybe experimental model will be very interesting to understand this process in the field.
For Taiwan, I think microplastic is evolving because during the COVID-19, all of our residents cannot go abroad, especially Japan is our favorite, but everyone was climbing the mountains. So we put a lot of unseen plastic into the woods. So during erosion, or rainfall, we find a lot of plastic is moving into the water, but unseen, like clothes or some things. And we find them in some of our fish bodies' stomach. Very interesting. And they feed themselves to death. So we're some from National Zhongxin University, Professor Lin is also doing this big project for the wetland of upstream and downstreams, and they are doing this for I think the recent 3 years. It's a big project from upstream to downstream, and we're trying to find what is going on in the river, especially where there is mountain routes, camping sites, or something that influence the upstream bodies of the river basement catchments. So I think they are doing real-time monitoring systems. They are collecting the data, especially for salmon fishes. The Professor Ye has been doing this project together with this team, but he is majoring about the habitation and also how the sediment is transferred from upstream to downstream, because downstream we have some reservoirs concerning that due to fish is going up, we have to open the check dams, sabo dams, and releasing sediment is going into the reservoir. But the reservoir contains not only sediment, also micro plastics inside the water body. So this water directly goes downstream. But for Dajia River, I think we are concerning that the sedimentation will also affect the hydropower system. So some of our students here, we're going to proceed the JPGU next week in Tokyo. So they are trying to find results due to climate change. The Reservoir Bureau is still wanting us to know which part of sediment is coming and what should we face the problem. Are we going to track the sediment? Are we going to track the microplastics? Or sometimes some of the professors that are into insects, they find that insects are eating the microplastics, and the fishes eat the insect for food, and also there are microplastics on the leaves of the trees. So the fish jumps out and eats the leaves or insects together, and they find microplastic inside their bodies. So they are researching about the chain of food in the upstream area. I think that's a very big project for the national park of Xueba. And
which university are you?
National Zhongxin University, NCHU, Professor Lin Zhizu, Professor. Yeah. So I think his results might be, I can send this result because we're in the team too.
Yeah, maybe we will have, inshallah, some chance to visit Taiwan this year. We may, you and the Professor Yolo may organize
Okay, sure.
some seminar,
Yeah, good.
invite these people, and I will bring some of my group, and then we can have a good discussion.
Welcome.
That would be very interesting.
Okay.
Okay. Okay, so some other comments? Time? Do you have any questions or comments? If not, let's finish. And thank you very much for coming today. And I hope for you a very good continuation for your visit and safely back to Taiwan. When you go back?
Maybe next week.
Next week.
Some of the students are going back, but
Okay. Thank you.
have a small omiyage. Sorry.
A connection with Taiwan,逢甲University and Chungnong University, NTU, of course. And we hope to continue this every year. So last year we started a new project with NTU as well, and in Zhengun Reservoir.
Yeah.
And we hope to have a connection. You really have a good connection with逢甲University? The software. Yeah. So we are connected. I don't remember the name of the professor. I met with them last year. Our Zhengun Reservoir, they are doing sediment replenishment, numerical modeling, and monitoring. Yeah. Okay, very nice to meet with you. So please introduce yourself and your group, and if you want to have some skills talk, it's okay.
Thank you. Professors and students, good morning. Sorry to be late because we were stuck in Uji station. And we got up very early this morning at 6 o'clock. We went to see because we didn't have time to go to the temple. So it's a good day and the sun is coming out. Well, this is I think it's the 11th day we are staying in Kyoto. So we have been a very busy 10 days. And we visited both 3 of the campus already. And this is the last stop for the whole tour. And we have learned a lot. Basically, our students are 4 of them are master degree students, and still 1 chasing the train, PhD students. Okay, and basically hydraulics is their major, and some are in PhD are in architecture, and also some in EMBA, and also in green energy. So PhD program includes a lot of things. Basically in Taiwan, we have 3 major topics that is going on. One is sediment erosion is still the basic topic. Hydraulic induced landslide, induced debris flows, and also hydraulic usage and restoration and recombination. So our students are still working on it, and basically we have to additional add other things like carbon is also the topics we are learning right now, and due to soil loss and erosion that will use the soil carbon, and also blue carbon is also something we are doing, and some are involved with green energy like hydraulic energy, and also the waste use energy. So a lot of things are doing because we are facing problems in Taiwan, lack of nuclear power. Although we have 3, but right now 2 is shutting down. So that means we are in lack of energy. and green energy is the policy of our government. So this is a very big issue for all the universities in Taiwan, trying to find clear and good, but reliable energy. That is something we're trying to find, but still having trouble, and we're finding our ways to solve it. And I think most of our students are good in not only software, Professor that has mentioned, and also I think they are in practice of how to maintain construction, and also we consider ecological health and do a lot of investigations before and during construction and after construction. So this is very important also. So this time our students came, and we have learned a lot, not only from the flume test that we have solved this past 2 days in DPRI, and also irrigation systems that are Indonesia PhD students. So yeah, and yeah. So I think this is our basic topics that we have been learning, and I think many years ago, 7 years ago, Professor she has come, and sorry for the bad news that Professor Xu has passed away Sunday. Yeah, Sunday, just Sunday. Yeah. Yes. So due to liver cancer, so he won't be able. But I think he is very happy to see us to cooperate with DPRI and also Kyoto University because the last time was 2018, so 7 years ago, and we all have we follow the pictures that Professor Xu has taken. So every spot he has gone, we took the pictures again. So well, we look forward for the future cooperations, and I think Taiwan. I think last time they say that 7 universities and government agencies are still in cooperation with DPRI now, and I think it's very special for us to learn each other. And our purpose here, not only to take students to this place, and we hope in the future we can do projects together, and we all invite scholars and students to come to Taiwan. And we talked about many things that maybe we can get our financial budgets to bring scholars and cooperate with 1 or 2 individual topics that we can do together. So we're looking forward maybe next year or future we have the opportunity. So thank you all.
Thank you very much, Professor Lin. This is very nice introduction, and this is really very bad news for me about Mr. I knew him since 2001.
Yeah.
But unfortunately, we are always communicating and meeting in IHR conference.
Yeah.
So I was expecting to meet with him in the next IHR, inshallah, in Singapore, but unfortunately he passed away. My condolences for that. Okay, so I think building on what Professor Lin mentioned, we have started last year already one project with NTU, and we installed several cameras in Zengwen reservoir, where professors from Puncha University, they have a good communication with us as well.
Yeah.
Inshallah, in the future, we hope we may have one trip for our laboratory to Taiwan. We may go to NTU and Punjab, but not very near, maybe after a couple of years.
Okay.
Okay,
Yes.
so I will try to introduce our research activity in the lab, okay, to give you very large overview, and then students, Dr. Guan Bing is a JSPS fellow of my laboratory. He will make introduction for his research, and then Mr. Chaumet Desmond from Cameroon, he will introduce, and then at the end, Engineer Wei Ching from Taiwan, she will introduce her topic. We have 3 Taiwanese students in the lab, 3, very unique. So it's very okay, so my name is Sameh Kantouche. I am a professor at Disaster Prevention Research Institute. Okay, so, sorry, I moved a lot. Okay, so I am a full professor. I specialize for dam management, sediment management, flood management. Associate Professor Kobayashi Sohei. He is specialist of the ecosystem ecology, river ecosystem, and Associate Professor, appointed Associate Professor Dr. Muhammad Saber is specialist of AI and machine learning and flood management. And then we have a visiting professor, Professor Fahid Nourani. He's staying with us as a JSPS fellow as well. He's here attending with us. And Dr. Guan Bing, he is JSPS fellow, postdoc researcher from Vietnam, and series secretary. So here's our students, all of them with their name. You cannot memorize it. But just introducing, some students' pictures are not here, but almost all are here with their specialty. We have a very big group from PhD student. Yeah, please feel relaxed to have a drink. And we have master students, not so much, and also 1 bachelor student. So in total around 24 students. So here, this is showing our laboratory. It's a kind of hazard map for member countries of the lab. You can see we have almost 11 countries from different places in the world. And this is a kind of showing the hazard with high, medium, low, and very low for different countries. And the sharing point of all countries, they have a very high flood risk in most of these countries, even in Africa, even in Southeast Asia or other places. So just to give you a very short introduction, that we are studying more about the river basin from the mountain until the sea, from the mountain area until the delta, and we are trying to understand how much or quantify the flow or runoff volume, sediment volume moving, and if we have infrastructures, then how this will affect on the continuity of flood and sediment and the impact on the river ecosystems in the downstream and until reaching to the delta. So we have different topics for hydraulics and hydrology as well, from rainfall runoff modeling, from the hydrodynamic modeling, and also understanding the dam impact, where the sediment trapping will be increased and many human activities like sand mining or other activities related to the human impact. But also we have a natural driver like climate change and causing flood risk, and also sometimes, as we said, we have, due to climate variability, too much water in a very short time, but also it happened too less water where drought may occur. So we are trying to study all of this about flood management, sediment management, ecosystem management related to all this river basin integrated point of view. So, for instance, you can see here, once we have this infrastructure, then the coastal erosion may happen, and the sea will retreat the line of the land, and then intrusion of salinity and causing several impacts on the river ecosystem like bank erosion and flood risk. But at the same time, we have, this is in the humid environment, but we are also working for the arid environment, or we call wadi system. Wadi means dry river. Dry rivers, and also will be filled with water with more than 10 liters or more during flood. We call flash flood. Okay. And this dry or arid environment river is really very big. For instance, we are focusing on the Middle East, North Africa, where we have lots of studies in most of these places to understand the flash flood and also the hydrology of this area. They have the same problem once they construct dams for the, they have something they call recharge dam, because the water itself is very valuable for them. They have less water, but they are receiving too much water in a short time, 6 hours or so, so they are interested to harvest this water to recharge in the underground. Therefore, they construct a series of dams, retention and recharging, but they have many problems because of clogging in the under soil because of the fine sediment, and also suddenly release of the flow causing flood in the urban area. So they have also problem with the sediment management, flood management, and we are trying with Commerce Sensei to study in the future about the ecosystem in this region as well. So here I put flood in Oman, and also here is the dam. This is the dam, you can see all of this. It's a kind of embankment, very large dam, and the reservoir is full, and they start to release in the downstream like this. So one of the important things, the infrastructure causing a lot of impact on the river system. So once we construct a dam, we have forming the delta, reservoir delta, and fine sediment will be deposited, medium size and very fine, coarse sediment will be deposited, medium size and fine sediment will be here. So important issue about the climate change is most of our infrastructures are not resilient for the climate, because climate variability increase, maybe the runoff or rainfall by 20-40% or even more, 2 times more, but our dam capacity are limited, and dam are very aged, already fixed bottom outlet, fixed spillway capacity. How to upgrade, how to enhance the dam safety, okay, under the climate variability and many drivers due to reservoir sedimentation, and also improving the dam rehabilitation routine. So as I said, loss of functionality drastically in the presence of climate change event and the natural, or let's say extreme events. So this is the map for almost all dams in Japan. Japan, they have more than 3,000 dams. Okay, and as you can see, this dot showing no measures, no countermeasure for sediment management. It shows the unsustainability of the dams constructed. We have, in spite of the fact we have other dams located in this region. This region is very active for the fault, earthquake. That's why the sediment yield here are very high. And that's why most of the sediment management techniques are implemented in this middle region. They have a sediment flushing, as here. Flushing means we draw down the dam and then open the bottom outlet gates and releasing the sediment from the bottom outlet. Or we are doing also a kind of sediment sluicing with a partial opening of the gate, or we are extracting the sediment and bring to the downstream manually, we call sediment replenishment, or we do a sediment bypass tunnel as here in several examples in this yellow mark. So we have many research related to this. This is really very extensive work related. So this is just to show one example from our research about the Naka River. Today, Wei-san will introduce in detail this topic, maybe. We have the sediment replenishment, taking the sediment from the upstream dam and bring it to the downstream of the dam in these locations to be replenished to the downstream. Here the picture. So very large sediment volume are bringing every year. So we have this site and we are trying to monitor the flow and the sediment by using some cameras system installed in these two bridges. We have here one camera and another two cameras on the far bridge, so we can watch on a real-time basis. And then using this technique, we are using the large-scale particle image velocimetry, image treatment, to be able to treat these cameras' image and convert it to easily quantify how much flow velocity, sediment movement, or flow discharge in this location. These are some of the techniques. Also, Li Kun is also from Taiwan. He's doing this and he's trying to bring new topic using machine learning and coupling with the image treatment as well. So we have two different techniques, surface STIV and LSPIV, and we are using different techniques to compare, and at the end we have this beautiful flow velocity. This is not numerical, this is from the field, directly from the field. Based on the images, we can do the treatment and we can do. We are trying to follow the same style for the Zengwen Reservoir in Taiwan. We have installed maybe 3 cameras, three cameras, one still maybe in the processing already, working, fixed. 3 cameras are installed on different bridges in along the downstream of the Zengwen reservoir. We had our group meeting with Professor Lai, Professor Lee, Professor Yo, and NTU, and we had also very good group from Zengwen Dam, and also we met with 2 professors from Punjab University. I don't remember their names, I'm sorry. But we are, Yeah, you know. So we hope to collaborate and continue collaboration with this in the future. Okay, so I think I should take less time, otherwise other people will not introduce their work. But this is just a general methodology for what we are doing, okay? We have a real-time monitoring stations, flood, discharge, sediment transport. We are trying to do flood inventory and infrastructure information, so from the field, so from the data collection and verification validation. We are doing also field investigation in the questionnaire, rainfall data, topography, land use data collection. All of this are very important. Sometimes we use camera system, geophone for real-time monitoring. All of this will help us to evaluate, also using remote sensing data on based on statistical analysis, bias correction. Using the data from this part, data collection, then we have a rainfall runoff, inundation, and sediment erosion modeling using RRI model, SWOT model, telemat model, and now CCH 2D. Weisan is trying to use. We are also using Delphi 3D, so model, and some other modeling related to also flow simulation, flood depth, extent, sediment yield. This is this group, and then we using this. We are trying to use also climate change analysis, D4 PDF. This is a kind of data prepared more than 6,000 years in Japan by Jamstek Institute for decision support system. And using this data and after bias correction, we are trying to do extreme rainfall analysis, updating IDF curve for the infrastructure itself, as we mentioned. So coupling all of these groups, we try to use integrated flood, sediment, wadi ecosystem or ecosystem, urban and basin management for developing different hazard map and upgrading dam facility, risk-informed urban planning, flood mitigation strategy, and early warning for disaster risk and water harvesting, smart monitoring for smart management at the end. So this is one example of some project we conducted for flood management in Jordan, in Aqaba, where we tried to use a kind of risk-informed urban development, okay? Because usually the urban planning are lacking the linkage with the risk. Urban planners, they are trying to use or planning these roads, buildings, without having information in their background about the flood. Where this area will be high flood area, you can see. Based on the numerical model, we tried to show which area is very high flood risk. We are saying for the urban planner or architects here, please don't use this area, use it for agriculture, forest, landscape, more than use it for high value of infrastructure. But some other areas, some other streets are low risk, so it can be suitable for urban development because it's very expensive for urban planning as well. So this, the street scale hazard map is very useful to understand in detail which area are very high risk, which area are very low risk, and then this will help the urban planners to use. So our research is more applicable, not only theoretical, but we are trying to link with the real application and the development. This project, I tried to develop a very detailed location for upgrading dam, which area to improve, to reduce the future development. We call master planning for the city master planning. the city is really very vulnerable for flood every year, very big flood. But with the JICA, we tried to build this updated master plan for flood management in the Aqaba city in Jordan. That was a very good example to build a smart city. We call it smart city planning for the Aqaba, where transportation can be included, where urban planning can be included, tourist development, and flood management and disaster risk management as well. So we are doing a lot of work related to machine learning for flood susceptibility mapping, and this also have been produced by Professor Saber, and also here my student Asma, and also Professor Nourani. He's doing a lot about the machine learning and AI technique for the hydrology prediction, and maybe we will introduce later on. Here also this machine learning for soil erosion susceptibility prediction, and this is the study of Asma from Algeria. We are doing the extensive work related to this from the field, from the model prediction, and using different model related to soil erosion inventory. Also for water management in analysis using rainfall distribution from different climate, historical, near future, far future. We try to use that and link it with the water resources management or the existing dams and how this will affect on the future water resources in the country scale. So this work related to one of my students in Japan, Mr. Sin, also how to do the ensemble rainfall prediction and the flood mitigation strategy using different data and to prepare some scenario for dam operation. Because if we have enough information about the dam operation based on the historical or future that will based on D4 PDF, which we just introduced, or it's a kind of near real-time data with ECMWF, then we can use for the optimizing dam operation rule. We have also some project we call synergistic strategy for sustainable water resources. 3 of our group about Filipino students, they are working on that project to optimize the dam operation rule for flood and the drought risk management and how to improve the dam operation under 2 extremes, too much water or too less water, how to operate the dam, optimize the dam, and for one of the important dam we call Magat Dam in the Philippines. Okay, this is again sediment replenishment. I will skip, and as we just explained about too much water, too less water, the flood quantity and sediment quantity also are really very difficult to be quantified. This is Kobayashi Sensei study and focus on the how to quantify the sediment, how to quantify the flow, and the response of the river ecosystem and the river morphology and the habitat inside the river. This, we have many examples in Japan, as you can see in this Moru Dam, Naka River, here is also in Kurobe and other rivers in Japan. This is the same concept as just I explained about the ecosystem preservation and by sediment and river bed management, and this will help us to understand the river habitat and the relation with the suitability for the spawning bred of the fish. We are also doing several work related to nature-based solution using river flood ecosystem management using this we call SEGU. I think you saw this in the Uji and the
Open
Uji
lab.
Open Lab. So we are trying. It's a new project, just started this year. We are trying to use to improve the promotion of the riverbed erosion deposition in the sandbar, but we are interested to work on the river scale using also new concept from Switzerland we call river widening. And this river widening we are trying to promote coupling with this device to improve flood and sediment management. We have several research related to delta. Dr. Kwon Bin will introduce. Maybe I can skip this part to give more time for him about the sand mining activities and the Mekong Delta and the Vuja Tubon River Basin in Vietnam. We have also 3 Vietnamese students and also several other students from Cameroon, Swatini, Iran, China, as well as Taiwan and Japan. So I think I will skip some part. This is also advanced modeling and artificial intelligence for hydrological modeling. We are doing lots of research to predict flood, inundation, and the developing hazard map based on the AI techniques, and also for flood, not only for flood, but also for suspended sediment concentration and prediction in the future. We implemented in Algeria and Vietnam, in Syria, Oman, and Japan. Hopefully, we are trying with Dr. Saber to develop a global map for this hazard map based on this technique. Okay, so I think with this, I would like to stop here and listen to the next student. Thank you for listening. Maybe if you have any questions, we can keep it at the end.
Now scale 6.
Now scale 6.
很多我都是倒语。
Now 7. It's finished.
Finish.
我说才刚睡到没多久。
啥也是有点好玩了。但是后来有这种说法说，就是地震的时候不要躲在桌子下，其实反而是危险的，应该是躲在桌旁。
他们说躲
桌脚旁，不是桌下。对，桌下其实是错误的。
其实找结构墙，就找结构
墙。对，其实是找结构墙的墙角躲是最安全的，比躲在家具下还要安全。家具其实是骗小孩的。对啊，
感觉像我刚刚根本塞不下去。
是不是？所以你已经长大了，你不是小孩了。
土砂災害は大きく崖崩れ、土石流、地滑りの3種類に分けられるんだ。特に崖崩れが多く発生しているよ。大雨などによって土の抵抗力が弱まると急激に斜面が崩れ落ちるんだ。崩れた土砂が家を襲い、逃げ遅れてしまうと命が奪われてしまうんだ。